I've mentioned the concept of Monte Carlo events. So what is Monte Carlo? So it has a casino, and when you say something is Monte Carlo, you mean it's been generated randomly or statistically. And what one does is, and this you do in certainly all big physics experiments and lots of other problems as well, you generate fake events. And you have events that you record at the Large Hadron Collider, but also you ask a friendly theorist to give you a model. That model produces events, maybe they're Higgs events or maybe they're background events involving these Z particles. And then you take those events and then you generate from them the particles that those events have. You take those particles, you track them through the magnetic field of the apparatus, you track them through the hardware of the apparatus, the chambers and the calorimeters. You generate the signatures of which your electronics will give you, and then you write these fake events on disk, and that's a Monte Carlo event. Um, and LHC has generated endless Monte Carlo events. At least in some physics cases, I'm not certain this is true here, because in some physics cases you use these Monte Carlo events to do very detailed estimates of efficiencies. You would tend to generate 10 times as many Monte Carlo as real events. And so Monte Carlo events are very important. Actually, they were critical to making the software work, because whereas the Large Hadron Collider has only been switched on for a little time, people have been running Monte Carlo events through the software for 10 to 15 years. And so they had a very good test of the software, not just the overall system, but the details arithmetic. So when they ran the real events, then they were just, if you like the Monte Carlo events, and the software ran smoothly. And so you treat Monte Carlo data with exactly the same process as real data. And when the physicists list the amount of data in their experiment, they list the sum of Monte Carlo and real data.